Ever heard about the birthday paradox? Yes, the statement that states that in a room of 23 people, there's a 50% chance of at least two people having the same birthday. Well, this statement does not go too well with general understanding or thinking. It's just 23 days right out of an year of 365. The odds of a common birthday seems pretty less, nowhere close to 50%, right? So let's bring in a bit of mathematics. Let's see if we can get to our desired result. The pillars of truth are built on the most strongest of ideals. So are the fascinating facts finding their explanation where they're never searched for, the easiest of concepts. So, welcome back to Maths So Plain. On a recommendation from a viewer, we have started this weekly fact series. Feel free to write down any reviews or suggestion for the same in the comment section. So the statement says that in a room of 23 people, there's a 50% chance of at least two people having the same birthday. So an intuition or a general approach to this problem will be considering yourself to be a part of this group of 23 people. Now, what you may say is that I will do an experiment. I will go to each of the other 22 men and ask them their birth dates. This seems fair, right? The next step will be to check if any of these 22 men have the same birthday as me. So that leaves me to a favorable set of 22 dates out of 365. Thus, I may expect a probability of 22 by 365, which is nowhere close to 50%. So, where did I go wrong? Was it the counting? Partly, yes. Also, the concept of probability wasn't used properly. In an experiment, we checked our birthday with every other man, right? But what if the second and third man, or the third and 10th man, had the same birthday? How do we account for that? Thus, we need to restate our experiment to account these cases as well. So, now consider I conduct the experiment when these 23 men are standing in a line to buy tickets for the party. Now the first person checks the other 22 people for same birthday. When his work is done, he gets inside. Now the second person does the same, but in the absence of first man, he will check the other 20 men for the same birthday. Thus our count becomes 22 plus 21. Similarly, carry out this procedure unless we have no one left to count. So finally our count will be summation of 22 to 1, which is 22 plus 21 carry on till 1, which we can calculate using the formula for addition of first n natural number, that is n into n plus 1 divided by 2, which here becomes 22 into 23 divided by 2, which yields us a count of 253. Okay, we're done with our counting here. Now the next concept to be used is that of probability. Now say my birthday is on 7th of October, which is a day out of 365 days. Thus has a probability of 1 by 365 to be chosen. Now for any other guy to have the same birthday as me, the probability will be 1 by 365 multiplied with 1 by 365, that is 1 by 365 squared. Now according to the statement, we need at least two people out of the 23 to have same birthday. So let's deal with the simpler case of no two people having the same birthday, which has a probability of 1 minus 1 by 365, that is 364 divided by 365, and is also complementary to our statement. So probability of no two people having same birthday out of 23 people is 364 by 365 raised to a power of 253, as it was a number of checks or count. Now we need to subtract it from 1 to get a desired result, that is 1 minus 364 by 365 to the power 253, and the result turns out to be 0.5 or 50%. Yep, we proved the statement using basic mathematics. What if we extend the statement to a case where more people join the party, say making it to a total of 75 people? Why this particular number? Well, the result will tell you. Now we need to do the counting work again. So assemble everyone back in a line. Now the first person counts 74 men, the second counts 73, and so on till no one is left to count. Finally, on addition from 1 to 74, we get our total count as 2775. Now the only quantity changed in our probability formula is the count. So let's change its value. Now the result becomes 1 minus 364 by 365 to the power 2775, and the result is 99.9%. This is in a room of 75 people. There's a 99.9% chance of two people having the same birthday. So this was all from us today. I hope you enjoyed the video. Do like, subscribe and share with others who might be interested. And if you have any query or suggestion, feel free to write it in the comment section. Else you can mail me or message me on my Instagram. Link is in description. So goodbye till the next time.